Hello, this video is for IXL, activity 8.V.13. It is titled Multiply using the distributive property. And the 3-character code for this activity is uniform 7 tango. So we've talked about the distributive property in other exercises, kind of touched on it a bit in the upper SMART score levels of another activity. But this particular activity is centered around nothing but the distributive property. So I have this visual up here, this little scale showing that these two expressions are equivalent to one another. However, I don't really care for the use of the multiplication sign. We don't really have to use it. We could say that A times the quantity of B plus C is equal to A times B plus A times C. So let's kind of try to get away from using the little X there as a multiplication sign and realizing that the absence of an operation sign, such as between the A and the quantity of B plus C, note there's no operation sign here, and nor is there an operation sign between the A and the B or the A and the C. It's not necessary to put it there because if there's not an operation sign, we realize that it is indeed multiplication. So in this case, the A is being distributed to both the B and the C. And so this is A times B plus, because it's a plus sign between the B and the C, plus A times C. So we're distributing the A into the quantity of B plus C. So we'll do the same thing on each of these activities here. So we need to take this 3 and distribute it into the 9m and also to the positive 3. So 3 times 9m, and we're going to add that to 3 times 3. We're just distributing this 3 right here. Shows up here and here. It's being distributed to the 9m and the 3. The 9m and the 3. So with that said, let's clear that up a little bit. All right, so 3 times 9 is 27, and we bring down the m. It's still there. It goes along for the ride. And then we still have a plus, and 3 times 3 in this case is 9. So 27m plus 9 would be our simplified expression. And we talked about this whenever we did the textbook lesson, that we are creating equivalent algebraic expressions. Equivalent because they're equal to one another, and algebraic because it does involve a variable, in this case the variable m. Moving on to the next one, we have 4 times 2w, so 4 times the 2w, and we also need to distribute it to the positive 2, so it's plus 4 times 2, and 4 times 2 over here, it's going to be 8, and the w goes along for the ride. Add that to 4 times 2, which is 8, so we end up with 8w plus 8. Next one, 3 times the 2. It's going to be 3 times 2. Distribute it to the 3 to the value of 2. Now let's distribute the 3 to the 4h. 3 times the 4h. And this is addition between them. So 3 times 2 is 6, and 3 times 4 is 12, and the h goes along for the ride, so we end up with 6 plus 12h. If you really want, you could write it also as 12h plus 6. IXL will accept that as well because it is a true statement because of the commutative property of addition. Here we have 2 times the 5, 2 times 5, and also 2 times 9z, 2 times 9z, cross my z so I know that's a z, and it is addition, so I have 2 times 5 is 10, and 2 times 9 is 18, and the z goes along for the ride, so that's plus, not subtraction, so we end up with 10 plus 18z. On this next one, we have the 4 times the 4. So 4 gets distributed to the 4. And also we have the 4 being distributed to the 5f. So 4 times 5f. And that is subtraction. So 4 times 4 is 16. And 4 times 5 is 20. And the f goes along for the ride. And it is subtraction. So we have 16 minus 20f. On the next one here, now we got some negative times negative stuff going on right here, right? We have a negative integer out here, so negative number. And so we have negative 4. Distribute that to the negative 8. And then we also have that negative 4 being distributed to the 8 and negative 4 distributed to the 4s. And it is addition, so we'll put plus. So negative times negative is positive. 4 times 8 is 32. And bring down our plus sign. And then negative 4 times positive 4 is negative 16. And the s goes along for the ride. So we get 36 plus negative 16s. Now we could probably, and we probably want to go ahead and do this and simplify it a little bit further. Instead of having plus a negative, let's change the addition to subtraction and then take the opposite of the number that follows. So negative 16s, the opposite is going to be positive 16s. So we could rewrite 36 plus negative 16s as 36 minus 16s. So 36 minus 16s. Next one, negative 2 times 2y. Distributing that negative 2 to the positive 2y, and the negative 2 to the 5. Actually, let's talk about something here. I want to get you used to realizing that this is actually 2y plus negative 5. I could rewrite the 2y, change the sign to plus. The opposite of 5 is negative 5. So if we realize that this is actually 2y plus negative 5 is the same as 2y minus 5, then it makes it a little bit easier. We can kind of start taking shortcuts. We don't have to write everything out. We could say 2 times negative 2 is negative 4, and the y goes along for the ride. And 2 times negative 5 is, negative 2 times negative 5 is a positive 10, and we bring down our plus sign. So figure this is a good time to start pointing out the fact that minus a negative is the same, or minus a positive is the same as plus a negative, especially whenever we're distributing this 2 into each of those, realizing that this is a positive times a negative, or I'm sorry, this is a negative times a positive, and this is a negative times a negative, right? Because that's actually plus minus 5 if we can think about it that way. So let's try to start adjusting our thinking a little bit more in that direction and realize that we could rewrite this inside the parentheses. We could write this different as plus a negative instead of minus a positive. On this one here, we have 8 times the negative 3y, or negative 3m. So let's do 8 times negative 3 is going to be negative 24, and the m goes along for the ride. And then we also have the 8 times the 5, which is going to produce a positive 40. So that's plus 40. So negative 24m plus 40. And then we get to decimals. Oh, goody. So let's see. Let's go ahead and write this one out, I guess. So we're going to multiply this negative 6. We're going to multiply it times 1.4u. And then we also have negative 6, but this is, think of this as plus negative 5 instead of minus 5, so plus a negative 5. So it's going to be addition. Negative 6 times negative 5, it's going to be a positive 30. We can do that part there on that step. So now I need to multiply negative 6 times positive 1.4. So in this case, let's see, without doing it with a calculator, let's look at it this way. Let's do some writing on the side. We know it's going to be negative. Negative times positive is going to be negative. So 6 times 1.4. Let's think of this as 6 times 1 plus 0.4. So 6 times 1 is going to be 6. Distribute that in. 6 times 1 is 6, plus sign, and 6 times 0.4. Well, 6 times 4 is 24, and we have one number at the decimal place. You could check that out on a calculator, and that's going to be 0.24. And then this is going to be 6 plus 2 is going to be 8, and then the 0.4. So we get 8.4, actually negative because it's negative times positive. 8.4u plus 30 would be the final answer. So negative 8.4u plus 30. And the final two questions here. We got some decimal work going on. You could use a calculator, I suppose, if you like, with the decimal numbers. We really haven't gotten to where we multiply decimals too often, but you're going to need it at the upper levels of IXL once you get into the higher SMART scores. So this is we're going to distribute that 0.1 into the negative 7. Well, that's going to be negative, and 7 times 1 is 7, but we do have the one decimal place. So I'm going to go ahead and put a 0 in there. It always looks a little tidier that way. So negative 0.7, because that is a positive times a negative. And then also this over here, positive times positive is going to be positive. And any number times 1 is equal to itself. So that's 7.6. And I'll go ahead and write a 7.6, but I have 1 as a decimal, so the decimals are going to have to move over one more place. So we're going to end up with 0.76, and the K goes along for the ride. If you type this into a calculator and check it out, you'll see that you're good to go on it. So positive times negative is negative 0.7 plus 0.76, and the K goes along for the ride. Wow. Negative times negative is going to be positive. 2.6 times 2.4. I could use a calculator, but I won't. 2.6 times 2.4. And we don't have to line the decimals up. It just so happens to be that there's only one decimal place behind it. So we want to multiply this. So 4 times 6 is 24. Right? Not 28, but 24. We're going to carry the 2. 2 times 4 is 8, plus 2 more is 10. And then 2 times 6 is 12. And we're going to carry the 1. 2 times 2 is 4, plus 1 more is 5. And we end up with 4. 0 plus 2 is 2. 1 plus 5 is 6. We have one decimal place here and one decimal place here. 1 plus 1 is 2. So we need to move the decimal place over 2 places. So we end up with 6.24. That is a negative times a negative, so it's positive. So 2.6 times negative 2.6 times negative 2.4 is going to equal positive 6.24. And the M goes along for the ride. I almost missed that. So I took care of that. Now let's go ahead and multiply. Negative times positive is going to be negative. So for now, let's just put plus. Negative is, we know it's negative because it's negative times a positive. And then we have 2.6 times 4. 6, 6, 12, 24. Carry the 2. 8 plus 8. 4 times 2 is 8. Plus the 2 gives us 10. And we have one decimal place. No decimal places. 1 plus 0 is 1. So let's move the decimal place over 1. That's going to be negative 10.4. And then next, my mental math in that. Yep, that seems about right. So last thing I want to do is 6.24. Going to leave that the same. Bring down the M. Plus a negative. Instead, let's change the sign to subtraction. Take the opposite of negative 10.4, which is positive 10.4. And our final answer would be 6.24 M minus 10.4. Wow, a lot of work there. So like I said, you might want to try a calculator out with that. The idea is not so much multiplying decimals. It's great to know how to do that, but really wanting to focus on applying the distributive property to come up with equivalent algebraic expressions. And those are all of my examples for IXL 8.V.13, multiply using the distributive property. Good luck on your activity.